that last year or the year before that.
We'll talk about how to memorize them.
But it's in a pop quiz.
Study. Focus on your homework answers and then study them. And then look at bold terms in your book.
The homework wasn't over when we read. It was concept review, wasn't it?
It was, okay, on page 32, concept review, 1 through 3. And on page 35, concept review, 1 and 2.
Can that help us with quiz?
Maybe?
Yes.
Potentially.
How
The
come?
homework's
What was
supposed to
it
help
again?
you direct it.
The homework
Help you
reading
direct it.
30 to 33.
Jamie, hang on. The gentlemen are freaking out because they think that there's a pop quiz.
There
today.
is a pop quiz.
So you should be studying, Jamie, if you also want to get ready for potentially pop quiz, pages 30 through 33. And you want to look over your homework, page 30 through 32, concept review 1 through 3, and on page 35, concept review 1 and 2.
So
That's
just
the answer for
Jamie?
your homework. For Jamie or
I can
Quentin,
feel the anxiety building. I feel it building inside of me.
study. Jamie, they've been studying for about 2 minutes, 3 minutes as well, so if you want to pause the video and study a little bit extra, you can as well.
We can pause the video.
But the gentlemen are right, there is a pop quiz today. So Jamie, if you haven't studied in a minute yet, be sure you pause the video for it, but they've only studied for about 2 to 3 minutes. Make sure you're not studying too long.
And Rob.
Ignore that. Alright, and Quentin. Alright, so go ahead, gentlemen, clear your desk of everything. Jamie and Quentin as well. I mean, not right now, gentlemen. Go ahead and clear your desk of everything. Take out 2 pieces of paper. So you can use one of the cover sheets and one to actually take on it. You write your name
Cover
at the
sheet.
top. What?
Cover sheet.
Sit you far enough apart, okay, but make sure you have out at least 1 piece of paper. Label it 1 through 5, and this is the first pop quiz we've had so far.
It's been kind of counteracted by that yesterday. Yeah.
Name and date at the top, so today's the 25th, you should write your name. If you just want to write chemistry pop quiz, I will adjust the numbering later for it, it's fine. I fix it all online anyway. Remember, it's 5 questions, so 1 through 5.
That's helpful.
Alright, number 1. What is the term for an atom or molecule that has an unequal number of electrons and protons resulting in a charge? What is the term for an atom or molecule that has an unequal number of electrons and protons resulting in a charge? Number 2. What is a laboratory instrument is used to measure the masses of the atom? What laboratory instrument is used to measure the masses of an atom? Number 3. What unit is usually used to measure atomic mass? What unit is usually used to measure atomic mass? Number 4. What is the term for atoms of the same element that differ in their mass numbers? What is the term for atoms of the same element that differ in their mass numbers?
What?
Hang on, I'll go over it at the end. Number 5. Alright, listen to the following choices before you write down your final answer. What determines the identity of an element? Number of protons, number of neutrons, number of electrons. So what determines the identity of an element? The number of protons, number of neutrons, number of electrons. You basically have a 33% chance of guessing correctly.
Say your question one more time, please.
Which question? Question 4 and 5? Or just 5? Okay, number 5. This is for question 5. What determines the identity of an element? Number of protons, number of neutrons, number of electrons. Which one? repeating number 1. What is the term for an atom or molecule that has an unequal number of electrons and protons resulting in a charge? What do you call that type of atom or molecule?
Number 3 and 4.
Okay, number 3. What unit is usually used to measure atomic mass units? Number 4. What is the term for atoms of the same element that differ in their mass numbers?
Number 3.
Back to number 3. What unit is usually used to measure atomic mass?
One more time.
Which one?
Number 4.
Alright, number 4. You're gonna
What's number
use
two?
Jamie and Quentin. What is the term for atoms of the same element that differ in their mass numbers?
Number 2 is the last one.
Do you need number 2?
Yes.
Alright. What laboratory, number 2 for Jamie and Quentin. What laboratory instrument is used to measure the masses of an atom? What laboratory instrument is used to measure the masses of an atom? Anyone need more time?
Do the bonus since it's the first time, please.
Nope. Part of your homework. Anyone need more time?
Go over it.
Or do you need more time? Alright, go ahead and pass it forward then. Jamie and Quentin, please send it to me as soon as you can for it. Alright, now you can go ahead and take out your homework. Alright, number 1. What characteristic of an atom determines its identity as a particular element? Ethan, what you got?
Number of protons.
The number of protons determines the identity of the element. Number 2, what is the term for atoms of the same element that differ in their mass numbers? Chris?
Isotope.
Isotopes. Number 3, what is the term for an atom or molecule that has an unequal number of electrons and protons resulting in a charge? Ethan? What?
Nucleon.
Okay, that's whenever you have neutrons and protons together in the nucleus. Chris, what you got for that one?
Ion.
Ion is correct. Alright, now concept review on page 35. What unit is usually used to measure atomic mass? Ethan?
Atomic mass units.
Atomic mass unit. And then number 5, what laboratory instrument is used to measure the masses of an atom? Chris?
Mass spectrum.
Say it one more time.
Mass spectrum.
Yeah, mass spectrometer.
What if
So,
we put spectrometer on there?
what?
What if we put spectrometer on there?
On the quiz?
We didn't put mass spectrometer. We just put spectrometer.
Hmm.
Please.
So, as a side note, whenever you're going over your homework, you want to study the bold terms and the italicized terms. But you also want to use your homework to kind of help guide you. So, as you're probably going over the homework just now, you probably realize, wait a minute. So, make sure you are using your homework to help guide you. That's why I give you homework questions to help direct your focus. So, you for sure, as you're studying, want to know what your homework's talking about, and then also study bold and italicized terms. Is this a question about the homework or about the pop quiz? Wait, because I can't talk about the answers in case Quentin and Jamie haven't taken it quite yet, so we can't be super obvious for it. Alright, but yes, ask me after class. Alright, so you can go ahead and put that away. Now, we need to start doing, because what is happening on Friday, Ethan?
I do not know.
Oh, that's a bummer, Ethan.
Alright, please.
Quiz. Your test for chemistry is either going to be Tuesday or Wednesday, so I haven't decided which
Wait,
day
what?
yet.
Of next week.
Yes.
I thought to say.
No,
What?
not today, and not tomorrow. But it
Our
will
our
be.
U.S. history test tomorrow.
Tomorrow.
The U.S. history test is Friday.
About to say. I thought-
Friday. We gotta finish up the material tomorrow.
There was some tests we have tomorrow. What was it?
I don't know, not mine. Alright, so we played this before, so since we did, this is a good game to do it just back and forth really fast. So if you want to take a piece of paper to write down the elements that you don't know, so that way you will be able to start learning them. Because remember, when's this quiz, Chris? Friday. So you got to know them, have to know them by Friday. So make sure that you're ready when you're studying. Jamie and Quentin, if you can't see the card Chris, whenever I hold them up, I'm sorry, I'm trying. Make sure you're steady. Try to follow along with the gentleman as well. Alright, I think I started with Ethan last time, although we played it twice, so I'll start with Chris today. Alright, Chris, what is this one?
Barium.
Beryllium. Good job. Barium is another element, so beryllium. Alright, choose your spot. We're gonna say gravity applies this first time. If we have another game, we'll say gravity does not apply. That makes the game a lot harder.
If it doesn't apply?
If it doesn't apply, because you can win in like a 3D. Like you can start hovering up here and win in like a circle around you. So it gets
That
much
is
more.
super quick.
It depends on how observant the other person is. In some cases, it's really fast. In some cases, it's not. Alright, we'll say gravity applies.
Percentage.
Color.
Alright.
Alright. Ethan.
Starts with Z. That's copper.
Copper. Y'all are getting it.
9.
What color?
Blue.
Alright. Xeon.
3.
Alright.
Silver. No.
What's up?
Does that actually start with this?
It starts with S, yes.
Starts with this?
Starts with S?
Yeah.
Yellow powder.
Is that sulfur?
Yep.
I thought it was
Composite
silicone.
study.
I thought it was silicone.
Is it from
7.
Which one's silicone?
S-I.
That's the one hard one, isn't
It
it?
is a harder one.
And it doesn't start with an S, does it?
This one does. It does. Couple seconds because I gotta
Oh
go.
no.
Alright, Ethan?
Don't know.
Okay. Strontium. So, S-R. Strontium. Put off the side to study later. Alright, Chris, back to you. Neither one of you knew.
Oh, silicone? It's the one I knew you said, right? Wait, is it hard?
Sort of. Don't say it.
And I knew this one?
I don't know. I don't remember if you knew it yesterday or not. I don't remember if Ethan had it or you.
Silver?
Final answer?
Yeah.
Nope.
Tin.
10. Alright, Ethan.
What was it? They're like Latin?
Oh, it's like,
Long.
8.
oh, I don't remember. One of them is like antimony something. Like, it's weird.
It's gonna be a quick one.
That's just the next one, though.
And this one didn't start with K.
It does not. This one is completely different. So guess what we're studying?
What does it start with?
It's P. Bananas.
Potassium.
Potassium. I can't
You're
tell
not
you
the
bananas
favorite
on
answer.
quiz. I can't tell you bananas on quiz. So make sure you study.
6.
Alright, Ethan.
That doesn't start with an F, does it? Silver.
Final answer? Couple of the cargo.
Iron.
Iron. So, iron. Make sure you know it.
1.
That's not one. E. This is white.
I think it goes back to it, doesn't it?
It doesn't. Once you click on it, it's gone. You're red, right? I guess you remember. Alright. So you stole back Ethan.
Silver.
Silicon.
Z.
You see.
Z.
Oh, there it is. Right? There's a lot of these.
It's the one that he guessed, right?
I don't remember.
No.
Oh, no, not that one.
Does
Yours
it start with a B?
doesn't have to be.
Is it like barium?
Not barium, must be A. Which one?
Beryllium?
I think you're combining two. Alright, Ethan?
Bromine.
Bromine. Or bromine, that's how a lot of people say it. Alright, Ethan.
T.
Alright.
Magnesium?
This is magnesium. This is still white.
2.
Right? Ethan.
You start with P.
Yep.
And there's U in it.
Yep.
Yeah.
Roman or Greek? It's also used to be a planet.
Plutonium.
Plutonium.
Yeah, that's Roman. That's over, for Hades.
Yeah, so it's either Roman or Greek. I can't remember which one.
Hades is Greek. 4.
Nickel?
Nickel.
U.
Alright.
N-E.
N-E.
Is there an N in it?
Mm-hmm.
Is there an E in it?
Yep.
Neon?
Neon.
V.
Okay.
Is it circle?
Nope.
Silver.
It's a silver.
Oh.
Alright. Ethan.
Krypton?
Yep. Not helping.
I.
Alright.
Gold.
Gold.
Hmm.
You almost had it.
Yeah, I know. Let's go with P.
Ethan.
Aluminum?
Yep.
W.
Let me go over there so you can see. W. Right.
Yeah, let's start with an L.
Starts with O.
Let's start with an L.
Yes.
Yeah. It's the one I was answering.
Okay. So we're starting
Is it lithium?
lithium is correct.
Q.
Does it start with a C?
Yes.
R.
I mean, there's an R in it.
Yeah. Go on.
Okay.
Is
Against
it
steel.
chromium?
Chromium.
N.
Good job. Alright, let's play again.
I almost said X. Then I
I was
said
like, wait a minute.
That's what I was hoping you would do.
Wait a minute. Try to skip that. Alright, we'll let Ethan start this time since he lost. Alright, Ethan.
I don't care.
What is this one? Well, see, gravity does not apply. Just make it interesting. This gets hard really fast, so be aware.
AS.
AS.
That's arsenic. Is there an R in it?
There's an R.
Arsenic?
Yes. I was
I
like,
knew
I
it
would
was
have
around
taken.
he almost said acid last time too.
I would have been like, okay, I'll take it, but it's spelled wrong, so make sure you fix it. Okay. Gravity does not apply. Choose whatever you want.
Okay, percent.
You see one be blue?
Green.
Okay.
Let's start with an
No.
Wait, George, why?
No.
What does it start with?
Starts with an S. Table salt.
Sodium.
Sodium.
Oh.
Okay.
Does it get hard for you or hard for us?
For
Trying to find all of them. Or is it gonna
Oh,
be
it's- it's gonna be
it's
hard for
hard
us.
because like if someone gets 2 here, like just as like an example, that means they need to start blocking you off because once you get 3, you can now pick top or bottom to win. So it's one of those you have to think in advance, like, oh, I have to start blocking them early and be aware. Okay. What color do you want to be? Do you want to be red?
Fine.
Okay. Alright, Ethan. Whoa.
Even though it's not.
Iodines.
You done?
V.
Did you say V?
Yep.
Okay. Whoa. Kind of doesn't matter about it, since we're
Doesn't start with an H, does it?
Yes, it does.
It's not hydrogen. Hydrogen.
Hydrogen.
Ooh.
That's hydrogen.
It was T. Hydrogen was a gas.
Alright, Ethan.
Zinc.
Zinc.
Zinc. The only reason I know what zinc is one base perfect, so where's the pond monster?
Alright, we gotta hurry because I gotta
J.
remember. J. Alright. Chris.
Does it start with an A?
Yep.
R?
RA, yes.
Radium? No.
Say it one more time, you might be saying it different.
Radium?
Yeah, radium. That's something else this time.
P.
Alright, Ethan.
Oxygen.
Yep.
Q.
Why is it slow? Okay.
Right. Start with an?
Yep. What?
No.
I just couldn't hear you.
Is it
Pencil.
nitrogen?
Nitrogen.
C.
Alright, Ethan.
Helium.
Yep.
U.
I think Ethan's just on the defense. I don't know if Ethan's trying to win. I think Ethan's just paranoid.
Oh, I'm being smart about this.
Okay.
Bones, right?
What? Oh, yes.
Calcium?
Calcium.
One.
Ooh, I think I need it now. Okay, Ethan.
Argon.
Yep.
W.
I might have done it. Alright.
Is it radioactive?
Yes.
Radioactive.
Uranium.
X.
You might be kind of doomed. Alright. Ethan.
Chlorine.
Yep.
L.
Which one?
L.
L. Okay. Chris. I'm not sure what you're doing anymore.
Is it 14?
I
Yep.
know what I'm doing.
K.
Ethan, why did you not pick K? Because you could have won if you picked K. Because you could
Yeah,
have
they
went by
would've just
E.
picked E.
What?
They would have just picked E.
What?
Then you would
You
have
go
picked
get the eye.
green. Yeah. If you had picked here, if he picked here, you could have gone down here and still won. And if he picked here, you could have gone up here and still won.
I didn't have one down all three though.
Don't worry
Let's
about
just
it. Never mind.
continue the
Never
game.
mind. Never mind. We'll let Ethan win. We'll let Ethan go in his next level. Or
Chlorine.
whatever he's doing. Alright, Ethan, we gotta go.
8.
I have no idea what you're doing. That's fine. Alright.
Spraying it out. That's what I'm doing.
Ethan's just hoping just randomly he'll just.
Oh no, not right away.
N.
You gotta answer the card!
RN. Does it have an R in it?
Yes.
Hen. Is it
I don't know how to like help you with this one. This is not a common one for us.
is it when
Nope. Right.
Radon.
What?
Radon.
Radon. Alright, Ethan.
7.
I don't know. I don't know anymore. Okay. Chris, back to you.
bananas?
Nope, that's potassium.
Start with a P?
This is not P. Other fertilizer.
Phosphorus.
Phosphorus.
9.
Yes, is that, does it start with S-T?
Yes.
Or is that in it?
Yes.
Calcium?
Nope.
Yeah.
Doesn't have an
I
S
said
in
no,
it?
I said no.
Okay. Alright,
CS, can you move that?
this is kind of a weirdly pronounced one.
I go back over my old notes.
Oh, cesium. Cesium. Make it up for it.
I hate
Is it
that
his turn or my
word.
turn?
I'll go back to his since neither one of you do. I'm about to run my cards over.
PB?
PB.
Start with P?
No.
It doesn't?
Nope.
What's, give me a hint.
Starts with L.
An L?
L. Ugh.
L.
L.
And what is it in?
Nothing, hopefully.
What do you mean nothing helpful?
Okay, I gotta go to Chris.
Lead.
Lead.
Oh my goodness.
Lead. Okay.
2.
Dang it.
Go. Okay.
That's green.
Oh.
He's red.
What? Is that every time?
I'm sorry.
I just placed these. Alright. Back to
I'm
you.
not gonna win, so it's fine.
No, quickly.
bro.
Alright, Ethan.
HG, silver.
Final answer?
Mercury.
Mercury. AG silver.
Hmm. 3.
I give up. I got time to give up. Okay.
Now I'm just going way defense.
CO.
I didn't mess up a little bit.
Is there a
little
C
bit.
in it?
Yes. I think you had this yesterday.
I had it right.
I don't remember.
What is it in?
We can use it to make blue like ceramics. But I have no idea if that helps you at all. Alright, Ethan?
Cobalt.
Cobalt.
G.
Is that G?
Yep.
I think about Ethan entirely. Alright,
PT.
PT.
Yes.
No, you're thinking of potassium.
What is sir?
This is the most valuable metals that they can help you.
Platinum.
Platinum.
It's the most valuable metal?
Yep, today, because of how much we use it.
Why?
Alright, Ethan.
Barium.
Yep.
S. Oh crap.
Nope, don't say that in my class.
Dang.
You've already clicked it. Alright.
I wasn't thinking.
I'm sorry.
I said
Sorry.
something.
Something
Yep.
in.
It has an in it.
I got this confused with something yesterday.
Yeah, it's not magnesium, it's the other.
Ah.
Not the
Manganese.
other. Yep.
Z.
Yay!
As soon as you said magnesium, he knew.
I'm sorry. Alright, what's this last one, Ethan?
I don't know.
It's C A.
Calcium.
Calcium. Did I have to pass some cards on? I asked that earlier. Alright,
You did.
so make sure you're studying. I must have 2 cards in them. Alright, make sure you're studying them. We don't have time to go over because that took way too long,
But-
but I gotta go. But make sure you're still studying.
I'm trying to play a tripper game, but I messed up on.
It's okay. It's okay.
You're making it a little obvious. You're either gonna go for
I
R
wasn't
or J.
making it obvious.
Alright, we gotta go. Turn over
I
to
would have had
page
it if I could take the
number.
right number later.
Alright, 26. We were talking about cathode rays. We were talking about the different discoveries for them. We talked about this yesterday.
26?
Yeah, 26. Talking about the different types of models they were using to help describe it. Yeah, no, that took way too long to have to talk fast now. So cathode ray, or the Crookes version of it, they would shoot electrons. Electrons would try to come down here to the anode section. That's why it's called the cathode rays, because it comes off the cathode portion. Now, they would put in objects and they would realize that, hey, it's being blocked by an object. So that means it's a substance of matter on the inside of it. So, just making up for that, that was kind of the discovery of the electrode with Millikan's oil drop experiment. But the scientist wants to know the scientist as well with their experiments, the first and last name. He used this to discover with the charges on the oil drops to discover the mass of the electron and also the electron charge. Make a note that he determined the electron's charge, which in turn allows the electron's mass to be calculated. They discovered it was very, 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 very small. So now they know, okay, we have a negatively charged object in matter, and it's very, very small. But they know, okay, not everything is negatively charged. So if you have a negative object, what do you have to do to balance it out, Ethan?
Positive.
Positive. So they knew, okay, there has to be some positive stuff then. Alright, quick question.
We're doing a video today.
What?
We're watching a video today.
Nope. I just have to go over here because all of my animations are on this computer, so I'm sorry, Jamie, putting this one off to the side right now. So they were looking at to see, okay, what's the positive portion? Whenever they would use basically a version of the cathode tube, they would use one though that had holes in it or that is perforated, so that way it has these little kind of circles on the inside of it. So it took almost up the exact way, but they would notice, hey, it seems like there's a different substance coming off it and this side for it. That's because as you have the electrons shooting through it, the negatively charged electrons or ions are basically charging or giving a partial charge to the gas on the inside. We'll talk more about this a little bit with electricity later on, but if you have a bunch of a negative stuff flying by a gas, as it's going by over and over and over again, that negative charge starts to attract or cause a positive charge on the gases near it. So because of that, the positive gas starts to be attracted to the negative portion of the cathode, of this cathode tube. But since there's holes in it, some of the ions would miss and fly through and strike the other side. So scientists were going, okay, these objects are the positive part then because they're striking their side. They're attracted to the negative part of the cathode, but they're missing it. They're going through those holes. So because of that, they named them protons. So they use these canal rays. So they named them after the idea of a canal is kind of like a hole or kind of like a river. So that's the idea of as they're going through these holes, they're striking the other side. So just make a note, these types of Crookes tube or cathode ray tubes with the holes in it, they called them canal rays because they didn't know what was coming through the holes. But eventually they decided, okay, these are the protons. These are the positive sections coming through it. They eventually found the mass of the proton was about 1.673 times 10 to the negative 24. Still very small, but it was 1,836 times larger than the electron. So they said, okay, this object is still extremely tiny. Yes, Ethan?
Excuse me?
Yeah, it's still small, but it's a lot larger than an electron. We'll talk about comparing them in a little bit. All right, anyone have any questions about canal tubes, about these canal rays and the protons, how they were discovered? All right, next page. Nucleus. So now they know, okay, there's negative stuff and then there is positive stuff. So they're trying to say, okay, what makes up the center of an atom then? So they're trying to figure out how does it work. J.J. Thomson came up with this early model for it with the plum pudding model. Sorry, wrong slide. So he came up with this plum pudding model. It looks kind of like a chocolate chip cookie. So sometimes students refer to it as that. But make sure that you note the real name for it is the plum pudding model. What he said is, okay, you would have a sphere of positive junk, all of it together, the sphere of positive charge, and you would have electrons basically put in it or shoved in it. So plum pudding model, make a note for that one. It looks kind of like a chocolate chip cookie. Yeah,
That's what it's called?
That's what his model is called, the plum pudding. Yeah. We would say today it looks closer to a chocolate chip.
And he's a scientist?
Yep.
I ain't never seen no pink cookie.
Nah, again, they just colored it, but again, if you want to think of it as like that, it's a plum pudding model. If you want to think of it as kind of like a fruitcake as well, where it's the stuff embedded in it. That was the idea of electrons. Okay, wait, we can't keep going. But no, plum pudding model. J.J. Thomson came up with it. What? Yes. Plum pudding model. So he came up with the idea that, okay, it must be a large, like, positive sphere, and you have the electrons shoved in it throughout. Now, scientists, as we were studying this, they discovered this doesn't quite work with our experiment. Your book talks about the gold foil experiment, so Hans Gregor and Ernest Marsden, that he started working with to see, okay, would this quite work, and does it work right? What they did is they took a very thin sheet of gold, because gold is non-reactive, that's part of the reason why they chose it. This will come for girls' earrings. If you get sterling silver, or gold earrings, whenever a girl gets her ears pierced, typically they'll use solid gold because it won't react with like the blood and sweat and stuff on your ear. It's a less chance of causing a reaction.
It won't turn blue.
Yeah, and it won't turn the feathers for it. Yeah, that's the reason why.
Oh, so that's why people wear gold and stuff.
I had a lip piercing when I was 7.
What?
Okay, we gotta go. Alright, so this is Gregor Marsden. So they basically shot a very thin piece of foil with some ions, so high-speed helium ions, and they noticed that some of it would bounce back. And they said, okay, if this is a giant sphere with itty-bitty electrons embedded in it, if we shoot it with ions, we should not have anything bouncing back. It should just plow straight through it over and over and over and over again. we should not have it ricochet off anything. So that was telling them, okay, if it's ricocheting, that means it's striking something and bouncing back off of it. So they're saying, okay, this doesn't match up with what we're actually discovering. Fast question?
Yes. How can they tell if it's bouncing out back or not?
They would measure the, your book has a model of it as well with the zinc sulfide screen, seeing, okay, where the ions bouncing off onto like the screen around it.
They can see the ions through those microscopes?
It's been a long time since I've looked at how their experiment worked. This is typically a simplified version for it, but I believe they could see where it like struck at kind of like X-rays. If I remember correctly, but it's been a while since I've looked it up. But they could see where it was like basically bouncing off of it into the areas around it. So again, they were looking to see, okay, where is it coming from? So because they were saying, okay, we should not have, these ions are so large, they should not hit an electron and bounce off. They should just plow through whatever is there. So the fact that this is ricocheting or bouncing off made them realize, okay, there's something larger in this than just the electrons. There has to be something there for it. So they said, okay, there must be a small dense nucleus. That's where most of the positive charge has to be. If you were to put all the protons together, that should be large enough at that point to cause it to bounce back. So they said we need to have a slightly better model for it. Alright, so that's what they were saying, that the gold foil experiment explanation, that most of your helium ions go through mostly empty space. But occasionally you would strike the nucleus, and that would cause it to bounce or ricochet off of it. So that's what they're saying, okay, this must be closer to what we're seeing then. Because if it was like the plum pudding model, it wouldn't work like that. But this is the reason why I have a dense nucleus, then that would cause my ions to bounce off and ricochet. So that's what they're trying to show, and that's what the picture in your book is showing you as well. Alright, so that's the gold foil experiment to help see, I should not have put that
Gold
up.
foil.
Gold foil experiment to see that a better model was needed.
Like that's what it's called.
Yep.
Gold foil.
Yep. So
Okay.
just making note that the gold foil, the gold foil experiment set up technically of the Gregor and Marsden's experiment, but it's typically just called the gold foil experiment. That's how I would refer to it as. So if you see gold foil experiment, you know what I'm referring to. Alright. So Rutherford, he said that okay, we need to have a better explanation for it. So Rutherford, he came up with this kind of model for it. This is the one that we basically associate the most with an atom. This is not quite accurate today, but because it makes sense, we still use this model a lot. This is the one you probably see the most. But it's the idea of you have the protons on the inside. They didn't know quite about neutrons yet, but they knew that the protons were on the inside of it. You have the electrons orbiting around it like planets. That's what comes their model. His model is called the planetary model. So Rutherford's model, also known as the nuclear or planetary model, he was saying that, okay, the nucleus is made up of all the positive charge, and you have all the electrons flying around on the outside, orbiting it, like the planets orbit the sun. Now, your book points out as well to give you an idea over the differences of size between the proton and the electron and how far apart they are. The nucleus would be about the size of a marble in the center, while the electrons are the dust floating around it in the stadium. So that gives you an idea over how large the atom is, but how small the individual protons and electrons are. But it's those positive and negative charges that make them stick together. They don't have to be right on top of each other. It's that they can be that far apart and still be attracting each other.
So in the picture, the marble is like the nucleus.
Yep, way in the center. And then all the electrons are like floating around in the stands. But that's what atoms are mostly empty space, but you stack up all those atoms together and they eventually make all matter of the universe. So just make a note, so that gives you an idea over how far apart they are. They knew though, okay, that the mass of the elements doesn't match up with just having just protons, and electrons are so small that they basically don't count. So they're saying, okay, there has to be something else on the inside to make this atom weigh this much. So they said, and so for that, Rutherford proposed the existence of a neutral particle because he said, okay, we have the negative stuff and the positive stuff, so there must be something else and it must be neutral. So a neutral particle, it was proposed. Sir James Chadwick, he conclusively demonstrated the existence of a particle. He called it a neutron, partly because it's neutral. So that should help you to remember neutrons are neutral. It's slightly heavier than the proton. Now, keep in mind, do positive and neutral stuff normally stick together. So why does it stick together?
I don't know why, it just doesn't matter.
No one knows why. It actually bothers scientists. We have no idea why it sticks together.
It's a pain.
Scientists just know it does. And we don't know why, and it bothers scientists, but they just have to ignore it because they say, okay, this is one area where science, we just don't know why it does it. It just does. And we don't know why it happens to do this. So just make a note, protons and neutrons are together in the nucleus with all of the electrons and negative charge flying around on the outside. Alright, I had to talk fast to get through that. Anyone have any questions though about the different experiments? Who did them? What do you know about them?
Who did this?
Moving on. Alright, so quarks. We gotta talk about quarks really quick. Alright, who wants to read first? That gives you a chance to use your voice.
Me, I guess.
Okay.
When the proton and the neutron were originally discovered, it was thought that they were invisible and could not think they far. In the middle of 26th hour, scientists discovered that protons and neutrons can indeed be split into small fragments. These small particles accelerate around galaxies. These discoveries just show that scientists still have a long way to go to understanding matter.
No, Willie, stop there. I lost my place over where you were. Alright, Chris, you take up for him.
Most scientists now think that protons and neutrons, the building blocks of the atom's nucleus, are actually composed of smaller particles called quarks. The two types of quarks, named the up quark and the down quark, are thought to compose protons and neutrons. Even if each of those quarks is about a third as massive as a proton and neutron, the up quark has an electric charge of positive 2/3, while the down quark has a charge of negative 1/3.
According to the
Good
quark
job.
theory, it takes 3 quarks to make a proton and neutron. The proton represents two up quarks on one down quark. Their combined electric charge gives proton a charge of 1 plus positive 1. The neutron is composed of 1 up quark and 2 down quarks. The quark electrical charges cancel, making the neutron equally neutral.
Alright, last paragraph.
The quark theory is supported by a great deal of experimental evidence and greatly simplifies study of particle physics. However, individual quarks have never been observed. It is thought that if the quark theory is correct, the quarks bind together so strong that it is impossible to separate them long enough to observe an image.
Good job. So, is this a hypothesis, theory, or law then, Ethan?
Yeah,
Is this a hypothesis, theory, or law? We've never actually seen them.
theory.
Yeah, so it's one of those. This is the best guess, and it seems like it works based on evidence, but at the same time, we've never actually observed them. So again, this is one of those, it works mathematically, and most of our scientists go, okay, this must be it, but at the same time, we don't know officially. We may never know.
You
So,
guys know this?
yeah, do note that it's a quark score. So this is for a proton over how they say it works. So you have 1/3 charge is positive, sorry, 2/3 positive, 2/3 positive, 1/3 negative. And so they cancel out, so you get a whole positive 1 charge for the proton. You don't have to know the math for it, so don't have to memorize the different parts for it. That's what kind of they call them the positive and the negative one. For a neutron, because they have to give it a neutral charge, they say it's 1/3 negative, 1/3 negative, and then they have one section that's 2/3 positive, so that way they cancel out entirely to get a neutral charge. It's also found that they say, okay, this works out mathematically to get the neutrons and protons together, but at the same time, we don't really know. So you don't have to know the mathematical parts of it, but you know that they think protons and neutrons are made up of these things called quarks. Alright, any questions about that? Alright, so different properties of the elements. Now, you're going to officially talk about this much later on in your textbook, but it's introducing a couple of important terms in this section for it. You have 4 basically different types of substances you can have with the elements. You have atomic number, mass number, isotopes, and ions. Now, those terms sound kind of familiar, and I'm sorry. So make sure that you memorize which one is which. The atomic number, this is the number of protons in the nucleus. This determines the identity of the element. Carbon, if you look at the periodic table, you can't see it from your angle, Jamie and Quentin, I'm sorry. But if you look at the periodic table for this one, and look at the one in the back of your book as well, they tell you typically how many protons it has. I believe in your book it's in the top left corner. So carbon always has 6 protons. If you have 7 protons, you have nitrogen. You can't have carbon with an extra proton. It does not work. If you were to take 1 proton away, you have boron. So carbon, all carbons have 6 protons, yes.
So none of those hope to have the same.
None of them have the same number of protons. None of them. This is one reason why if they were to take uranium, which has 92 protons, and split it apart, it turns into, eventually, with the different types of radiation, it turns into lead up here.
So-
I gotta find lead before I lost my phone.
So if you do that from oxygen, it goes, you take one away from oxygen, it's nitrogen.
Yep. That's the reason why we have nuclear Fusion is because they're literally taking apart an element and breaking it in the protons and they're dividing it up. And that's how come it releases so much energy, is because the number of protons typically is going down. Fission is whenever they're hooking them together. We can't do that very well. So that's the reason why the number of protons is always the same. You don't have to memorize how many element, like which element has which number of protons. You don't have to know that. Just make a note that if you have carbon, like if carbon normally has 6 protons, it'll always have 6 protons. If you increase the number, you are now jumping elements entirely. The number of protons cannot change. This determines the identity of the element. We give it a symbol Z to represent it. Okay, I know, just about time. Alright, you want for tonight? You're going to read pages 33 through 35. 33 through 35. We'll skip the application for right now. We'll come back to it because we haven't practiced a whole lot. Answer page on page 35. The concept review number 3. So that's your only problem because we haven't practiced enough of this yet, but we're going to practice some more tomorrow. So page 33 through 35. Answer on page 35. The concept review number 3.
When did you break this? Was it?
And then study.
Was it in what last night?
Yes.
Study periodically.
What?
Study periodically.
Yes. Study it. Make sure you are ready. All right. Thank you. Back over it. Never mind. Bye.
Is it like 10